Ahoy hoy. We're going to go through two examples of different quadratics in different forms. Okay, neither of these are in vertex form. We're going to put them into vertex form. These are both in the worksheet that I gave you, FYI. We'll underline that. So this, you might recognize, this is problem number 1 in the worksheet. This is in standard form. Standard form. This is in neither vertex nor standard form. You know how I made a big deal about intercepts with lines, right? This I like to call, this is in intercept form or the zeros form. We're going to talk about that, okay? Not on this video. Right now, I just want to take both of these and put them into vertex form, okay? This one's more involved than that one. This one's still pretty involved. And we're going to talk about the math required to do that. Okay, we will get into a lot of details about this when I get back. But let's look at this for first, okay? I'm going to zoom. Ding, ding, ding. Same music. Ding, 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 ding. Ding, 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 ding. Ding, 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 ding. Oh, come on, zoom. There we go. Can you see it? Are we zooming properly? A zoom, a zoom, zoom. Okay, so let's just, for our own sake, let's figure out the A, B, and C. A, B, C, easy as 1/1671. All right, so we can use this and our axis of symmetry, right? Axis of symmetry. That's how I write it. Negative b over 2a, and then we utilize this to find our vertex. Right, we can do all this, but let's sidebar that. We'll use that to check our work later. Okay, we did that already. So we want to get this in the form, this form, y equals x minus h quantity squared plus k. Well, how do you do that? That's hard. That's hard. It has to do with factoring and completing the square. Okay, this right here requires us to complete the square. If you've done this before, that's awesome. If you don't remember factoring, that's a rough one. We're going to do a lot of this when I get back, but I just thought I would introduce this if there's time and if there are questions, okay? Let's see what we can do here. All right, what you really are looking for is something here that can then be squared. So what you actually look for, and we'll have a whole different sub-lesson on this. In a perfect square, okay, x plus a quantity squared. Maybe you learned this once before. You will have, when you FOIL this out, do you remember this? First, outer, inner, last. Remember it's the distributive property on steroids. You end up with x squared equals 2 times ax plus a squared. We can do all this. We will do it all, right? X plus a, x plus a. Does this make sense? This symbol means we do this twice. One time, twice times. Okay? And then when we multiply it out, we multiply the firsts, we get x squared. We multiply the outers, we get ax. We multiply the inners, we get ax. We multiply the lasts, and we get a squared. We add them together, we get x squared plus 2ax's plus a squared. Okay, that's what we're looking for. So what we're looking to figure out for this, for us getting it back into here, do you see how this is a very similar form to this? Okay, similar form. We are looking to, we're always looking for patterns, right? So I see that, I recognize, if I can see this pattern and take this analysis backwards, then into here, then I can figure out what I want my form to be, okay? So I'm going to do this once, and then what I'm hoping for you, I actually think there's not going to be time for do this one today, just even taking this in now. So practice this, all right? We're going to do a Zoom. Are we close on the ding-ding-a-dings? All right, ding-ding-a-ding-ding-a-ding-ding-ding-ding-ding-ding. Yeah, we got room. We got room. I'm going to Vanna White this thing, and I'm going to stand here now. So we've got this going on, yeah? Right here. We are going to look at this term, this x term here. See? See we have x squared, 16x, 2ax, and 71. 71 is a prime number, so that is definitely not an a squared. But let's see what might work. So we want to analyze this part, okay? That's the thing that's useful to us right now. Okay, it's like you're driving on the freeway, you're learning how to drive, and you're on the freeway, and you're like white knuckling it because you're going fast, right? And there's a bunch of stuff happening on the other side of the freeway, but that has nothing to do with you right now. Yes, it's the freeway, yes, it's driving, yes, there's people, right? Don't be a gawker, don't have gawker delay. Stay to what you're doing, okay? This is what we're doing right now. The rest of this, for now, is gawker delay, all right? Let's not waste our time. So we want this, and we have to analyze it to this, okay? So 2a and 16. What's our a? Now again, I don't mean this a. I mean this one. Should I use a different number? I'll use an n. Should I use n? I'll use n. Let's say n. Let's just throw caution to the wind. We're going to say it's n. Okay? And because otherwise we're going to confuse our a's. Thompson sometimes forgets. These are placeholders for ideas. Like here's where my golf ball is supposed to be on the putting green, right? I forget though that you guys, it's okay. I did it too. Get hung up on what the letter is. So we're gonna say it's n. Okay. A was meant for any number, n can be meant for any number as well. So we're looking for twice the number we're looking for is equal to 16. So twice the number we're looking for is equal to 16. We're looking for n. Okay? That means what's our number? Come on, folks. Our number is 8. N equals 8. Woo-hoo! Okay, all right. Okay, awesome. Our number is 8. That means this number is 8. So I know I can take this, and I know for a fact I want this. I'm prepping this. We are not done. We need this bad boy out here though, right? You see already how my form is getting close? Okay, but we need this. The plus what? Because I've got this pesky 71. What is it supposed to be? I need to figure out what goes with the 8, and then I manipulate the 71 to get what I want. And that's the doppelganger at the end. It's all on the up and up, as my mother would say, all right? I'm finessing it how I want because I know what it's supposed to look like in the end, right? So if I FOIL this out, so let's just hold this. This is where we're going to put our answer, okay? This is where we're setting aside the product we want, okay? It's like we're trying on clothes, right? These are the ones we're going to keep. So we're going to put this over here for a second. Now we're going to analyze because we have to figure out now this 71. All right, now we're on the other side of the freeway. Now that messes our problem, okay? So let's again go back to this form. And if I speak fast, it's because I get excited, so feel free to review and then pause and then that's why they're on video. It's helping, then I can slow down, maybe. Okay, so let's look at this. If this is 8, if our n is 8, right? If we FOILed out 8, right? So we got the 2 times 8 was 16, right? What does this number become? It would be x squared plus 16x plus, what's 8 squared? Ding! 64. That number is really important to us, for us. You want to know why? All right, is everyone ahead of me? I'm going to give you a moment if you're ahead of me. All right, so now let's answer it. This 64 is super important for us because why? Let's go back over to our answer. Okay, this 64 is already in here, right? Because we got this because of x plus 8 quantity squared, that equals this. So this is our Halloween trick-or-treat bag. Oh, you can't even see that. I gotta zoom, I gotta lower my sights. Okay, how did I not notice that? Okay, this right here, the 64. Will you still need me? Will you still, yeah, you get it. Okay, it's already inside of this. This is our goodie bag. In the bag. This is opening the bag. Don't open the bag. Don't open the bag, okay? But the 64 is in here, all right? It's already in here. Let's go back to our problem, which I know you can't quite see now. All right, ready? We're excited. Oh, good. Just you can barely see both at the same time. All right, so let's go back to it. This thing right here is this. Okay, maybe you can't see, but that's an 8 in red. And there's the 8. Okay, so there's a 64 that comes out, and it's inside here. But what number do we have? 71. Okay, so we have 71, but 64 is in here, right? It's already in there. It's right there when we expanded it. But we don't want it out. Don't put it out of the bag. Put it back in. It's right there. Okay? So 71, that means what is left over? What needs to go right here? Question mark. What goes right there? We have 64 in here. We have 71 outside. It's like a cover charge. We got 64 people can fit in the theater. How many kids get left out? Sorry, kids. You're doing the arithmetic in your head right now, aren't you? 71 minus 64, that'd be 7. Boom. And now what have we done? We have found vertex form. What is the vertex of my quadratic? Of my parabola? What is the vertex? It is, vertex is, remember it's the opposite is, -8, comma, 7, vertex. Kaboom, kabang. Check that this is right in here. -b, -16 over 2a. 2 times 1, 16 divided by 2. -8, right? Because it was -2a. -8, plug that in, -8. We get 64, oh man, minus 128, which is -64, plus 71, which is, plus 71, which is 7. Oh man, when I rattle that off, doesn't it sound like all the stuff we just went through? There's a reason for that, because they're sort of inverse ideas of each other. We just rattled off the backwards to finding it. All right, let's not worry about this other one for now. Let's do this. Any problem that is in standard form, I want you to get it into vertex form. We're going to practice our perfect square trinomials. If you've never done that before, it's okay. Baby steps. Big Mama, Miss Thompson will be back to help you. But baby steps. All right, try it. DIY. Till then.